Students, welcome to Sunil's tutorial. I am Sunil Milwani and today we will be doing the numericals of electrostatics. Please take down a parallel plate air capacitor. A parallel plate air capacitor consists of two circular discs. A parallel plate air capacitor consists of two circular discs, each of radius 5 centimeters, each of radius 5 centimeters, and are separated by 3 millimeters, Another parallel plate capacitor consists of two square plates of length 5 centimeters, separated by 2 millimeters. The space between them is filled with a medium. The space between them is filled with a medium of dielectric 2. The space between them is filled with a medium of dielectric 2. What is the effective capacitance? When the two capacitors are connected? What is the effective capacitance when the two capacitors are connected? First part of the question, in series. Second part of the question, in parallel. First part of the question, in series. Second part of the question, in parallel. Now I can say for the capacitor with circular disc, area will be equal to pi r square. Right, I know the radius, so I can find out the area. Now I can say that capacitance C1 is nothing but epsilon 0 A upon D. So C1 will be equal to epsilon 0 A1 upon D. We know the value of epsilon 0, where epsilon 0 is 8.85 into 10 raised to minus 12 SI units. Fine. So I should get the value of C1. Now I can say for the capacitor with square plates, I can say that area is going to be equal to L square. So area 2 is going to be L square. Now in the second capacitor there is a dielectric constant also. So in that case this is going to be epsilon 0 K A2 upon D2. So I'll come to know my capacitance of the second capacitor also. Once you have this, now if the two capacitors are connected in, first part of the question, series. If they are connected in series, the effective capacitance in series is going to be nothing but C1 C2 upon C1 plus C2 in parallel. In parallel, the effective capacitance will be equal to nothing but C1 plus C2. So you should get this answer as, you should get capacitance in series, answer CS, capacitance in series is 11.32 picofarads and capacitance in parallel is 45.32 picofarads. Next, take on next one please. 4 identical capacitors are connected to form a square. 4 identical capacitors are connected to form a square. 4 identical capacitors are connected to form a square. Find the effective capacitance. Find the effective capacitance between. Find the effective capacitance between. First part of the question, any two adjacent corners. Any two adjacent corners second part of the question, any two opposite corners and third part of the question, what is the ratio of effective capacitance in the two cases. Third part of the question, what is the ratio of the effective capacitances in the two cases? What is the ratio of the effective capacitances in the two cases? Now they are saying 4 identical capacitances. Let each capacitance equal to C0. So this is C0, C0, C0 and C0. Okay, let's assume that each capacitance is C0. Now they are saying between two adjacent corners. Let's assume that the two adjacent corners are A and B. So I want to find out capacitance between A and B. I'm considering these two adjacent corners. Now that means as the current enters A, it will bifurcate and it will pass through the two branches. It will pass through AB and it will pass through AD. Now that same current will pass through AD, DC and CB. That means I can say that these three segments are in series. So I can say that the effective capacitance, yeah sure, just a minute. Effective capacitance of ADCB of that particular branch. See, once the current enters point A, that current will bifurcate between AB and CD. The current that enters CD, that same current will pass through DC, that same current will pass through CB. Since the same current is passing through it,
going from AB will also proceed that way, right?
See, this is my node. At this node, once the current comes into the node, you will have current bifurcating into two branches, two segments. Let's first consider this segment. Some amount of current has gone into segment AB. That same current will pass through segment DC. That same current will pass through segment CB. That means through these three segments, the same current is passing. When same current passes through a given set of segments, then those segments are said to be in series. That means I can therefore say that AD, DC and CB are in series. Let's assume that the effective effective capacitance of ADCB is say CS.
So
right?
my point here is, see, there is some amount of current is also passing from AB.
I'll come to that amount of current later.
Okay.
I'm first only considering this. We'll see that current also, don't worry. Right? Now let's assume that the effective capacitance is say CS. The effective capacitance is say CS. So I can therefore say that 1 upon CS will be 1 upon C0 plus 1 upon C0 plus 1 upon C0. That is the capacitance of segment AD, the capacitance of segment DC, the capacitance of segment CB. Therefore I can say 1 upon CS is nothing but 3 upon C0, common denominator. Therefore CS is going to be C0 upon 3. Now coming to this segment AB. Since the current has bifurcated at node A, the segment ADCB is going to be in parallel with AB. Some current is passing through AB also. So those two segments now will become parallel. So I can say that, I could say that segment AB and segment ADCB are in parallel. Their effective capacitance let's assume is say Cp. So Cp will be nothing but Cs plus C0, right? So Cs we know is nothing but C0 upon 3 plus C0, so that is 4 C0 upon 3. So the capacitance across AB is going to be nothing but 4 C0 upon 3. Fine, do we get this thing here? Okay. Now let's draw the four capacitances again. A, B, C, D. Right? Yeah.
Why did you consider AB over there?
Where?
Yeah, in series.
In series, because you have different currents passing here.
No, but you told that it is going in series from ADCB. So it will
And
come
then
back from B to A.
From here, when it comes here, it will go out here. Right? You will have current passing from here, that will also move out. Right? Okay. Now let's consider capacitance across AC. Right? First we had considered capacitance across AB. Let's consider capacitance across AC. The value of each capacitance is C0. The value of each capacitance is C0. Now, I can say that, now see this, current enters point A. The current is going to bifurcate into two branches. Some amount of current will flow through AD and that same current will flow through DC. So I can therefore say that you can say that effective capacitance of ADC, let's assume, is say C1. Let's assume that it is C1. Since it is in series, C1 will be nothing but C0 into C0 upon C0 plus C0. Right? I've used the parallel formula. 1 upon C1 should have been 1 upon C0 plus 1 upon C0. Or if you want, I'll write it that way and show it to you. 1 upon C1 is 1 upon C0 plus 1 upon C0, which is nothing but 2 upon C0. Therefore, C1 is C0 upon 2. Let's assume that the effective capacitance, let's consider the segment, capacitance of segment ABC, let's call it as C2, ABC, right? You have C0 here, you have C0 here, right? Same current is flowing through this particular segment. Let's call that effective capacitance as C2. So I can say 1 upon C2 is 1 upon C0 plus 1 upon C0, which is nothing but 2 upon C0. So C2 is C0 upon 2. Now, I can say that these two segments are in parallel. That means segment ADC and segment ABC are in parallel. I can say C1 and C2 are in parallel. Their effective capacitance say CP. CP will be equal to C1 plus C2. So that will be nothing but C0 upon 2 plus C0 upon 2. That is 2 C0 upon 2, which is nothing but C0. So the effective capacitance in parallel is going to be nothing but C0, right? They have asked you to find out the ratio. They have asked you to find out the ratio of the effective capacitance. So one is 4 upon 3 C0 and the other is C0. So the ratio will be 4 upon 3. The ratio of the effective capacitances is 4 upon 3. Take down another sum, please. Take down another sum, please. Find equivalent capacitance between points A and B for the following circuit. Find equivalent capacitance between points A and B for the following circuit. CAP, right? This is 2 microfarad, this is 2 microfarad, this is 2 microfarad, this is 2 microfarad, sorry, this is 2 and 3, this is 3 microfarad, and this is 3 microfarad, this is 3 microfarad, and this is also 3 microfarad. Fine. Now you have to find out effective capacitance between points A, B, right? Let's call this circuit as X, let's call this circuit as Y. Okay. Current enters point through point A. When it reaches the node, it is going to split into 3 parts. Some part of the current will go in circuit X. There are 2 capacitances in circuit X. Same current will flow through both of them. So I can say that effective capacitance in circuit X, let's call that as Cx. Since they are in series, I can say Cx is going to be 2 into 3 upon 2 plus 3. In series it should be 1 upon C1 plus 1 upon C2. When I simplify that, that is going to be 6 upon 5 microfarad.
What did you do?
I've used the formula C1 C2 upon C1 plus C2, parallel circuit formula, right? Now I can say that effective capacitance in circuit Y, let's call that as Cy. Now the current that is passing through circuit Y, there are 2 capacitors in circuit Y. Same current is passing through them. Since same current is passing through them, that means these 2 capacitors are in series. So therefore I can say Cy will again be 2 into 3 upon 2 plus 3. So this is going to be 6 upon 5 microfarad. The center capacitor is of 1 microfarad. Now let's find out the effective capacitance. The effective capacitance between AC, right? The effective capacitance between AC, you have Cx, the center capacitor, and Cy, which are going to be in parallel. Since they are going to be in parallel, let's call that as say Cp, right? Let's call that as Cp1 or Cp. So I can say Cp is going to be nothing but Cx plus 1 microfarad plus Cy. So this is nothing but 6 upon 5 plus 1 plus 6 upon 5. This is 12 upon 5 plus 1, that is 17 upon 5 microfarad. That's my effective capacitance of circuit AC. Now let's see, they have another circuit. Let's call this circuit as Z. From this particular node after C, the current is going to split into 2, right? That means the 3 microfarad and the 3 microfarad that I have, they are in parallel. Let's say that the effective capacitance in circuit Z is say Cz. Now since it is in parallel, therefore I can say that Cz is going to be 3 plus 3, just simple addition, so that's 6 microfarad. Now Cz and the Cp are going to be in series. This is going to give me, the capacitance between AC will give me one particular capacitance, and the capacitance between Cb is Cz. So I can say that the effective capacitance of the circuit say Cs will be nothing but, since they are in series, this will be nothing but Cp into Cz upon Cp plus Cz. Cp you found out as 17 upon 5 into 6 upon 17 upon 5 plus 6. Now you should be able to solve this and you should be able to get the answer. The answer for this should be, this is all in microfarads, right? So in that case, the answer for this you should get is 2.17 into 10 raised to minus 12. Make sure that you write the microfarad. This is into 10 raised to minus 12 and this is into 10 raised to minus 6. So your answer will be 2.17 into 10 raised to minus 12 farad. Picofarads you will get, right?
So how do you get that minus 12 and minus?
Because this is all microfarad. Micro is 10 raised to minus 6. So 10 raised to minus 6 into 10 raised to minus 6 will give you 10 raised to minus 12. And in the denominator you will take 10 raised to minus 6 common. 10 raised to minus 6 common. Right? Take down next sum please. Find the equivalent capacitance between points A and B in the following circuit. Find the equivalent capacitance between points A and B in the following circuit. The value of each capacitor is C. Right? Let's label the points A, B. Let's call this as CD. No, C we've already used. Let's call this as say P, Q, R, S, U, T. Right? Now, let's see this. Let's consider segment RPQ, guys. If I consider segment RPQ, the same current is going to flow through both the capacitance in segment RPQ. Same current is going to flow through both the capacitances in segment RPQ. Therefore, I can say that the two capacitances are in series. So I can say effective capacitance in segment RPQ, let's call that as say C1. So C1 will be C into C, since they are in series, upon C plus C, that is C square upon 2C, which is nothing but C upon 2. Right? That particular capacitance, guys, that particular capacitance is now going to be in parallel with the capacitance which is in segment RQ. So I can say that effective capacitance in segment RQ, let's call that as C2. Now effective capacitance in segment RQ, you're going to have this in parallel and you're also going to have, or let's, instead of RQ I'll draw say RS. Current enters this point, it is bifurcating into 3 branches, right? When the current enters that point, it is bifurcating into 3 branches. All 3 of them are parallel. Let's call that as C2. So C2 will be C plus C plus C upon 2. C2 will be nothing but C plus C plus C upon 2. So in which case this is going to be 2C plus C upon 2, 4, 5C upon 2. Right? After this stage, the circuit diagram would be something like this. this would be my circuit diagram where this would be AB, this is UT, this is RS, this capacitance is 5C upon 2, this is C, this is C, and this is C. This would be my new circuit diagram. Now, capacitance, let's consider the capacitance in segment URS. Same current is flowing through URS, so I can say that effective capacitance in URS, let's call that as say C3. Since it is in series, therefore I can say C3 will be C into 5C by 2 upon C plus 5C by 2. This is going to be 5C square by 2, 5C plus 2C, 7C by 2. 2 and 2 gets cancelled, C and square gets cancelled. This is nothing but 5C by 7. Fine. Now this particular capacitance is going to be in parallel with the capacitance in segment UT and segment US. So I can say that the effective capacitance across AB, let's call that as C4. So C4 will be C plus 5C by 7. This is 2C plus 5C by 7, 14, 19C by 7. So that will be my effective capacitance across AB. Fine, do we get this thing here? Next, take our next one please. Next, 4 condensers of the same capacity. 4 condensers of the same capacity when 3 of them are connected in parallel, when 3 of them are connected in parallel and the remaining one is connected in series, the effective capacitance is 3.75 microfarad. The effective capacitance is 3.75 microfarads. The effective capacitance is 3.75 microfarad. Find the capacity of each condenser. Find the capacity of each condenser. 4 condensers of same capacity, 3 of them are connected in parallel. So how will the circuit diagram be? 3 of them are connected in parallel. 3 of them are connected in parallel and one of them is connected in series with them. You have to find out the effective capacitance. Now since the 4 capacitors of each same capacitance, let capacity of each capacitor equal to C, right? Let's label the circuit, say let's call this as circuit X and this as say Y. Okay. Now I can say that effective capacitance in circuit X, let's call that as Cx. Since they are in parallel, effective capacitance Cx will be C plus C plus C, that is 3C. Now I can say that effective capacitance across AB, effective capacitance across AB, right? Let's call that as say Cy. Now I can say that Cy is going to be nothing but Cx into C upon Cx plus C, because those two capacitors, circuit X and circuit Y, are going to be in series. Cx is nothing but 3C into C upon 3C plus C, but the effective capacitance is given to you as 3.75 microfarad. Is nothing but 3c square upon 4c. Therefore 3.75 into 10 raised to minus 6 into 4 upon 3 will give you C. So in which case you will get C is 5 microfarad. The value of each capacitance is 5 microfarad. Right? Take down another sum please. 4 condensers of the same capacity. 4 condensers of the same capacity. 3 of them are connected in series. 3 of them are connected in series. And the remaining one is connected in parallel. And the remaining one is connected in parallel. Find the capacity, find the resultant capacity. Find the resultant capacity. Find the resultant capacity. Right? Let's see this. Now they are saying that the 4 capacitors of same capacitance. Let's consider this as A, B, C, D. Let's find out the effective capacitance. Capacitance in segment AB. Let's call that as say CS. So I can say 1 upon CS is 1 upon C plus 1 upon C plus 1 upon C. Right? Since they are in series, the 3 capacitors in segment AB, same current is flowing through them, therefore they are in series. So this is 3 upon C. Therefore I can say CS is C upon 3. Right? Now, I can say that this particular thing is in parallel, that is CS is in parallel with C. So effective capacitance of the circuit is going to be nothing but, say, let's call that as say CP. So CP is going to be nothing but C upon 3 plus C. This is nothing but 4C upon 3. So effective capacitance of this circuit is going to be nothing but 4C upon 3. Next, take on next one please. Find the effective capacitance for the following circuit. 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 A, B, value of each capacitance, C1, C2, C3 and C4, where C1 is given to you as 4 microfarad, C2 is given to you as 3 microfarad, C3 is given to you as 6 microfarads, and C4 is given to you as 6 microfarads. Okay, guys, let's see this. I can say here C2 and C3 are in series. Effective capacitance say, let's call that as CS. So CS will be nothing but C2 C3 upon C2 plus C3. C2 is nothing but 3 microfarads, 6 microfarads, 3 into 6, so 10 raised to minus 12 upon 3 microfarads plus 6 microfarads, 10 raised to minus 6. So this is going to be 18 into 10 raised to minus 6 upon 9. 2 into 10 raised to minus 6, that's 2 microfarads. Right? Now I can say C1, CS and C4 are in parallel, different current flowing through them. Effective capacitance CP, capacitance CP. So I can therefore say CP is nothing but C1 plus CS plus C4. C1 is nothing but 4 plus 2 plus C4 is 6. That's 12 microfarads. That's going to be 12 microfarads. Next, take on next one, please. The effective capacitance of two capacitors, is 7 microfarad when connected in parallel, and 6 upon 7 microfarad when connected in series. 6 upon 7 microfarad when connected in series. Find the value of individual capacitors. Find the value of individual capacitors. Let the capacitors, guys, be say C1 and C2. Now I can therefore say that CP will be C1 plus C2. CP is 7, is C1 plus C2. Therefore I can say C2 is nothing but 7 minus C1. I can say that CS is C1 C2 upon C1 plus C2. CS is nothing but 6 upon 7 microfarad is C1 C2. C1 into C2. C2 we have just found out is nothing but 7 minus C1 upon, let's leave the microfarad for the timing because we are not taking microfarad on the right hand side also. C1 plus C2. C2 is 7 minus C1. So C1 gets cancelled. So you will get 7 and 7 will get cancelled. So I'll get 6 is equal to 7 C1 minus C1 square. C1 square minus 7 C1 plus 6 is equal to 0. C1 square minus 6 C1 minus C1 plus 6 is equal to 0. C1 minus 6 minus 1, C1 minus 6 is 0. C1 minus 1, C1 minus 6 is 0. C1 is 1 microfarad or C1 is 6 microfarad. So when C1 is 1 microfarad, C2 will be 6 microfarad. When C1 is 6 microfarad, C2 will be 1 microfarad. Those will be your values of individual capacitors. Next, take down next one, please. The effective capacitance of three capacitors. C1, C2, C3. The effective capacitance of three capacitors C1, C2, C3 when connected in parallel when connected in parallel is 10 microfarad. When connected in parallel is 10 microfarad, and when connected in series is 30 upon 31 microfarad. 30 upon 31 microfarads. When C2 is removed from the combination, when C2 is removed from the combination, when C2 is removed from the combination, the effective capacitance in parallel and series, the effective capacitance in parallel and series is 7 microfarad and 10 upon 7 microfarad. Find the value of C1, C2 and C3. Find the value of C1, C2 and C3. Now they are saying that when C1, C2, C3 are connected in parallel, their effective capacitance is 10 microfarad. So I can therefore say that Cp will be C1 plus C2 plus C3. Therefore you can say that C1 plus C2 plus C3 is 10 microfarad. Let's call this as equation 1. Next, when they are connected in series, I can say that C1, C2, C3 upon C1, C2 plus C2, C3 plus C3, C1 will give you CS. That is the effective capacitance of 3 capacitors connected in series. Product of the 3 capacitors upon sum of 2 capacitors taken at a time. Right? So therefore I can say C1, C2, C3 upon C1, C2 plus C2, C3 plus C3, C1 is CS. CS we found out is 30 upon 31. 30 upon 31 microfarad. Call this as equation 2. Now they are saying when C2 is removed from the combination, when the capacitor C2 is removed, right? In that case, my effective capacitance in parallel will be C1 plus C3, which they've said is 7 microfarad. So C1 plus C3 is 7 microfarad. Let's call this as equation 3, right? And I can say that C1 C3 upon C1 plus C3 is 10 upon 7 microfarad. Let's call this as equation 4. Right? Okay. Now let's solve equation 1 and 3 simultaneously. Solving equation 1 and 3 simultaneously. If I solve equation 1 and 3 simultaneously, equation 1 says that C1 plus C2 plus C3 is 10 microfarad and C1 plus C3 is 7 microfarad. If I subtract the two equations, minus minus, so I'll get C2 is nothing but 3 microfarad. I'll get my value of C2, right? So once I have the value of C2, then I can say that, so in that case C1 plus C3 they've given you is 7 microfarad, which I can substitute in equation 4. From equation 4, C1 C3 upon C1 plus C3 is 10 upon 7, but C1 plus C3 we know is 7, so C1 C3 upon 7 is 10 upon 7. 7 gets cancelled, so C1 C3 is 10 microfarad, in which case I can say C1 is 10 upon C3, right? Now once I have this, I have the value of C1 C3 as 10 upon 7, then I can say that if I solve equation they've given you C1 plus C3 is 7, but C1 plus C3 is 7. So instead of C1 I can write 10 upon C3 plus C3 is 7. So I'll get 10 plus C3 the whole square is equal to 7 C3. C3 the whole square minus 7 C3 plus 10 is equal to 0. I can solve the quadratic and get the answer. So this will be nothing but C3 square minus 5C3 minus 2C3 plus 10 is equal to 0. C3 minus 5 minus 2 C3 minus 5 is 0. C3 minus 5 C3 minus 2 is 0. So either C3 is equal to 5 microfarad or C3 is equal to 2 microfarad. When C3 is equal to 5 microfarad, C1 will be nothing but 10 upon 5, that will be 2 microfarad. When C3 is 2 microfarad, C1 will be equal to 10 upon 2, that is 5 microfarad. That's how you get the effective capacitance of the three capacitors, right? Okay, we'll stop this here for the day. Thank you very much.